step. This is number 9. And we're in chapter 10. And this is a 2-sample confidence interval for difference in means. I mean, yes, we're dealing with means instead of proportions, so your equations will change, your normal condition will change, your words will change, but process-wise, it's really pretty similar to what we've done. So where do I start with state? And I'm going to start by defining what? U1. So mu1 is going to be our mean something for what? In general, what am I going to put here? This is like my success. So this is going to be my population. And then same thing with whatever my second one is. And so we're doing an interval, not a test. So what do I write here? We want to, what? What do we want to estimate? And then what do I have to do there? So if I am specifying which direction I'm subtracting. And then how does that always end? With whatever percent confidence level. All right, so plan, what's my first part? And we are doing how many? A 2-sample. I get a decision today. It can either be Z or T. What word for today? Interval. or difference in means. I'm going to check my conditions. What's my first condition? Random. Same way we've always done this. Whichever way you usually write it. And then because we're in chapter 10, I need to write what out here? For both? Now, can I literally just write the words for both and be done with it? No, because I need what there? I need some what? I need some context. Because I have to actually specify what the both are. What's my next condition? So, how many options do we have for normal? 3. But I also have 2 different samples. Technically, can they each be from a different one of the 3? Yes. I don't know that I've seen one. I may have given one in a problem that was like a classwork assignment just to show you that it can be, but usually they're pretty much all the same. So what would my first method be? It doesn't matter which one you said, which one? So it would have to be stated that both population 1 and population 2 are what? Normal or approximately normal, depending on the wording. What would another method be? So if I use central limit theorem, I would need that N1 is greater than or equal to 30 and N2 is greater than or equal to 30, which is still using central limit theorem.
Is there a sentence you write after central limit?
No, it's just the words. It's like sometimes people write n equals this or because.
Okay, but there's no.
Or my last option would be what? And it is a histogram of values for both. So it would be 2 separate histograms, and then we're checking what 2 things? No strong skew. No extreme outliers. And sometimes people say fairly symmetrical is no strong skew. If it is fairly symmetrical, then it doesn't have a strong skew. That's fine. And regardless of which one of the 3 I use, I still finish with, so I can use no approximation. And then my last condition, independent, which is going to be exactly the way we did it yesterday. Nothing changes there. So I'm still doing 10% condition, which means my first capital N1 has to be greater than or equal to 10 times lowercase n1, and capital N2 greater than or equal to 10 lowercase n2. And then however you choose to write this. So at least 10 lowercase n1 in population 1 and 10 lowercase n2 in population 2. Alright, what am I going to need? I'm definitely going to have x bar 1, x bar 2. Some people usually like to put like standard deviations with each sample. I might write it that way. I don't care how you write it. What else do we have from each sample? What else? What? What else we're going to have from both samples? Standard deviation, so it's going to be sigma 1 or S1. Which one did I say we're going to see most often? S. So almost always it's going to be S, but it can be sigma. So it's going to give us our confidence level, and we use that confidence level to find if it is T, then we technically have a what?
Yeah.
But I'm going to get a little bit funny about that, where I'm actually probably not going to have you write that. But I'll explain it, and we'll get there. Okay, so my equation, we've already written this. Technically, it can be either one. So it can be x bar 1 minus x bar 2. And if you'd rather write just one and right off the side, can switch out for these, that's fine.
You need test statistic.
What?
Test statistic. Do we know it?
No, so right now we're doing interval, and then so I might write that right now. And then so usually we write our answer. What's going to go here? Which again is going to be that direction that you specified initially. Alright, I'm going to go ahead and talk about this now, even though we don't have a problem in front of us. Why, or can you think of why degrees of freedom might be an issue? How do we get degrees of freedom? Sample size minus 1, right? So why do you think this might be an issue?
There's two sample sizes.
There's 2 sample sizes. So now what? If we are trying to be conservative, which one would be more conservative? Using a lower sample size or a higher sample size? What happens as your sample size gets bigger with T? Gets closer and closer to what? Z. Which one's more conservative, Z or T? T. So which would be a more conservative? A lower number or a higher number? A lower number. So if you did it that way, you would choose your lower N to do degrees of freedom. And I'm saying if you choose it that way, because if you run a test, your calculator's going to do it for you and do this really, really long equation that's about this big about how to find your degrees of freedom, and you don't have to write it down, just do it. It does it all for you. And I'll show it to you when we get there. So I just avoid this anyway, so that if I use the calculator, I'm not writing down something that contradicts what I did in the calculator. And then, so my conclude is going to be what? So for an interval, it would be we are confident, level % confident that what? And then you specify your direction again. And then how do I end it? Falls between. What do we sometimes have here and sometimes we don't? Units. Are we going to have units if it's means? Yes. Or we should. Sometimes you get those weird questions where the units don't make sense, but yes, theoretically we should have units for mean.